Okay, so this is kind of just a brief reminder of the strategies that we've already used, and then a new strategy we're going to try. So factoring out the greatest common factor, here's an example of it. Using factoring quadratic trinomials, perfect square trinomials, the difference of squares, which remember is 1 plus 1 minus, and then factoring by grouping. So we've done these things. The last thing is the sum or difference of cubes, which is what we're going to be practicing here. There's even a little trick we're going to have to be able to remember how to factor it. And we will get into those examples in just a minute. Okay, so we've kind of already talked about examples like this. We need to make sure that all factors are on the left side. So I'm going to start by moving the 3x over by subtracting it. So I get 2x to the third minus 5x squared minus 3x equals 0. Next, I look for the greatest common factor that I can factor out of all these terms. So I can factor out an x squared. Or, I'm sorry, not an x squared, just an x. So I can factor out an x, leaving 2x squared minus 5x minus 3 in parentheses. And then finally, I want to factor this quadratic, which means I am going to do that one of several ways. Any of the ways that was on that list of strategies. We can find the factors by doing the quadratic formula. We can find by factoring by grouping, anything we want to do. So I am actually going to do it by grouping, and I'm going to write my work right down here. So 2x squared minus 5x minus 3. To do factoring by grouping, I multiply, I get negative 6. And my two factors are going to be negative 6 and 1. So I'm going to change this to minus 6x plus 1x minus 3. Okay, so this is just me using factoring by grouping to solve. Okay, and I've used factoring by grouping to solve, so I've factored it. So for the second one, I still need to move this over. So I'm going to subtract 6x to the third. And for this one, I'm going to need to factor out more than just an x. I have a common factor of 3x squared. And in parentheses, what I have left over. So 3x to the fourth divided by 3x squared. I have x squared left over. Minus 2x plus 4. And now I am going to go ahead and use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac over 2a. And I'm just going to go ahead and fill this work in. So it's going to be a positive 2 plus or minus the square root. Okay, so doing the quadratic formula, I end up with 2 plus or minus. I'm pulling out an I here. And then I can also simplify the square root of 12. That is going to simplify to 2 plus or minus. This will be 2i square root of 3 over 2, which is actually going to simplify even further. Since they have a 2 for each of these terms, one in the denominator and one for each term in my numerator, I can actually eliminate that 2. So my two answers for my quadratic are 1 plus or minus I squared of 3. And then to figure out the solution for my 3x squared, I set that equal to 0. Divide by 3. Okay, and I end up with x is equal to 0. So my three solutions are going to be x is equal to 1 plus or minus I squared of 3. Sorry about that, that's my dog. Zoe, shh. Zoe, shh. And x is equal to 0. Stop. Okay, sorry about that. Anyway, so here is the U-tray problem, which you need to write in your notes in order to get credit. Okay, now what are the real or imaginary solutions of each polynomial equation? So this is when we have a quartic polynomial. This is going to work similar to what we've done before. We're going to start by subtracting 4 from both sides. So we get x to the fourth minus 3x squared minus 4. And what we can actually do is go ahead and factor it. Before, when we had quadratics, we'd take that x squared and we would split it into x and x. Now we have an x to the fourth power, so we can actually split that into x squared and x squared. And then the rest of it works the same way. I'm still looking for two numbers that multiply to give me -4 and add to give me a -3. And those numbers are going to be a -4 and a +1. That's really all there is to it. This isn't the only way that we can do it, but this is probably the easiest way, as long as we have real solutions. So then we would take these and set them equal to 0. Okay, and solving, we would end up with x squared is equal to 4. When we take the square root of each side, we'd end up with x is equal to plus or minus 2. And then for the second one, this is going to give us imaginary solutions, it looks like. We're going to get x is equal to plus or minus. Remember, the square root of I is equal to square root of -1 is equal to I. Okay, and for the second one, we're going to go ahead and subtract that 18 from both sides. So x to the fourth plus 7x squared minus 18 equals 0. So now we are going to factor again. So the x to the fourth, we're going to split that into x squared and x squared. And then the two numbers that multiply to give us a -18 and add to give us a +7 are going to be a -2 and +9. Meaning that when I set up my two equations here, solving for the actual solutions, I'm setting them both equal to 0. So I end up with x squared is equal to 2. Taking the square root, I get x is plus or minus the square root of 2. And then for this one, this is going to be an imaginary solution because I'm going to get x squared is equal to -9. And when I take the square root of that, I get x is equal to plus or minus. And remember, if I have a negative under the square root, I change that into an I. And the square root of 9 is going to be 3. So it's actually plus or minus 3i. And here's the U-try problem. Okay, and so now we're looking at cubic polynomials, factoring these using the formula that was on the other page with the strategies. So I need to take each of these, and I want to find what the cube root of each of these are. The cube root means what number can I multiply times itself 3 times to give me that term. So the number that I can multiply 3 times to give me 8 is going to be 2. And the number that I can multiply 3 times to give me x to the third is x. So 8x to the third is the same thing as 2x to the third. This is the cube root of 8x to the third. The cube root of 27, the number that I can multiply by itself 3 times to give me 27, is 3, right? 3 times 3 times 3 gives me 27. So I'm going to go ahead and rewrite this again. This is the same thing as 2x times 2x times 2x. And this is the same thing as 3 times 3 times 3. So now I'm ready to go ahead and set up my binomial and my trinomial. Anytime we factor a cubic polynomial, we're going to get a binomial and a trinomial. So for the binomial, the first term, what we're going to do is we're going to use one of these 2x's, okay? That goes in the first term of my binomial. So I've used that 2x. The second term is going to be my second term of my binomial that I started with. I'm going to use that 3. So I've used one of my 3's. Okay, my first term of my trinomial is going to be my other two 2x's. It's 2x squared. So I'm using these 2x's. Two 2x's. So 2x times 2x is actually 4x squared. So I've used both of these. And my last term of my trinomial is going to be my 3's. I'm multiplying these two and bringing it as my last term of my binomial. So 3 times 3 gives me 9. It's going to be my last term. The term that goes in the middle, I'm going to use a kind of like a little phrase to figure out what that number is. So what I do is I'm taking these on a roller coaster ride. Okay? So we're going to do a couple loop-de-loops. Woo, 1, 2, bam. That's going to help us out, okay? We take it on a roller coaster ride. That gives us our middle term. So we take 2x times 3, and that gives us whatever goes here. So 2x times 3 is 6x. And the last thing I need to do is figure out what the operations are, if it's a plus or a minus. So when we are going on a roller coaster ride, there are two things that we do. On a roller coaster ride, we can scream or puke. Okay, scream or puke. And those actually stand for same, opposite, and plus. Okay? So that means that whatever operation I started with in my original problem, I'm going to keep that same operation for my first one. This is going to be the same. Okay, sorry about that again. So same operation here. We do the opposite operation for the second one. And the opposite of a plus would be a minus. And then the last one is always going to be plus. So same, opposite, plus. Okay, so looking at the second one, x to the third is equal to 1. So I need to first move the 1 over. And I do that by subtracting. So x to the third minus 1 equals 0. So I'm following the same procedure that I did for my first example. Meaning I need the cube root of x to the third. That's the same thing as x, right? And the cube root of 1, which is still just 1. So that's the same thing as x times x times x. And the second one, that's the same thing as 1 times 1 times 1. So I am ready to go ahead and split it up into a binomial and a trinomial. Alright, so again, I use my first x in my binomial. So I've used one of these x's. Okay, the second term of the binomial is going to be the second term of my binomial that I started with. So that's going to be a 1. So I've used one of the 1s. Okay, next I am going to use the other two x's. I'm multiplying them. X times x gives me x squared. That's my first term of my second, or my trinomial. Then I use my 1s. So use my x's. I'm using these two 1s now. 1 times 1, still just 1. That's going to be my last term of my trinomial. So I've used the 1s. So I've basically used everything at this point. That means that I'm ready to do my roller coaster ride. So here I go. I'm going loop-de-loop around the first one, second one, and bam. That tells me what goes in the middle. So x times 1 is x. And now I can scream or puke. So starting with the first one, this should be the same, which means I take my minus sign. That's what I started with. That's going to be my minus, or my operation for this one. The second one, this is opposite, right? O is opposite, which means I had a minus sign to begin with. I'm going to make it a plus sign here. And then finally, the last one is just plus. It's always plus. Okay, so final answer is x minus 1 and x squared plus x plus 1. If you would like to simply memorize it, then you can. If you cannot memorize the rule, though, this is a really great way to remember it. The roller coaster ride, scream or puke. Okay, so we will always get one whoa, didn't mean to do that. One binomial and one trinomial. And we will solve using the quadratic formula. So we're actually not completely done here. We actually have to finish out our answer. The answers, when we do the trinomial, answers are going to be imaginary. So we actually have to go ahead and figure out what these are equal to. So I would take my binomial and set it equal to 0, take my trinomial, do the quadratic equation. And we will practice more of this in class. And don't forget to try the U-tray problem.